Okay, so this is going to be a present value and future value video, and I'm going to go through some examples that we had on our exam in accounting. If you have the test available, it was number 13, 14, and 15 on the test. So just a little bit about the spreadsheet that I built that you can obviously use, and that will be out there. This column is to find present values, depending on what the problem is. This one will find future values. And the idea is that the yellow fields are the input fields, so you shouldn't have to enter anything in the white fields. They should calculate for you as you do this. So the first one we're going to look at is this one here. It's number 13 on the test. It says Madison wants to help pay for her niece's college tuition. Her niece will begin college in 7 years, 7 years from today. How much would Madison need to put into an investment account today that will earn 8% so that her niece can withdraw $22,000 at the start of her first school year, September 1st. So begin 7 years, how much would you need to invest in the account today? So we're looking for, we know what the future value is, 22,000. We want it to be 22,000. We know the growth rate, we know the time frame. So we're looking for a present value in this case. So the future value, I want it to be 22,000. The term, 7 years. The type says and it's paid at the beginning. The discount rate is 8%, and there is no payment because it doesn't ask if I'm making multiple payments in the time frame like an annuity or an annuity due, which is a single amount. So the answer is that the aunt would need to invest $12,836.79 into an account that returns 8%, and at the end of 7 years it will be the $22,000 that we're hoping for. Now you can always check this to confirm that's true by basically filling out the answer you got, 12,836.79. It should come out close to the same. Payments, 8%, type 0, term 7 years, and if you do it right, the future value should come out to equaling the future value that you desired. And there could always be some rounding problems, but overall that should usually work for you. Next one is, it asks, what is the present value of receiving $9,500 at the end of a 10-year period using a discount rate of 7%? So this is one single payment, $9,500, 10 years from now at a rate of 7%. So again, I'm looking for a present value. 9,500 is the future value. The term is 10 years. Type again is 0. Discount rate is 7%, and there's no payment. So the present value of $9,500 discounted back to today's value is $4,829.32. And again, you could go to the future value and test this if you want to make sure that it worked correctly. Third problem says if you have $8,000 today, what is the future value of that $8,000 compounded quarterly for 9 years? Okay, so here's where it gets a little trickier because we have compounding multiple times a year. So I have two different ones here. This one really is for annuities, but I also built it so that it works a little better with automatically figuring your number of terms if you have multiple compounds per year. So if you have $8,000 today, so that would be a present value. Present value of $8,000. Future value for the discount rate is 5%. The problem is the discount rates are given on an annual basis. Since it says that this is compounded quarterly, we need to take this percentage, 0.05, and divide by 4 for the 4 times a year that it's been compounded. By the same token, or in the same way, we need to take the term, we take the number of years, and multiply it by 4. So it's 9 years. So equals 9 times 4, 36. Present value of 8. Type we're good. I'm not making payments, so there's your answer. The $8,000 today future value of that is $12,511.55. Now, this down here does some of that math for you if you want to do it automatically instead of having to put it in yourself. So $8,000, zero payment, term in years was 9, annual interest rate's 5%, annuity versus annuity due, and the compounds per year is 4. Notice it came out to exactly the same, but I didn't have to do these. I didn't have to divide these by 4 or multiply by 4 because effectively what I've done is I've written that into the function itself, so you don't have to do that. So you can use either one will work. It's just this one you have to manually convert interest and term, whereas this one I've done it so that if you put the compounds per year, it automatically adjusts for that. And we will stop that video or this video there.